Hello my dear students. In this video you are going to learn how you find the distance along parallel of latitude. That is the distance between 2 points that happens to be on the same latitude. So suppose x is a point. The location of x is gamma degree north latitude and alpha degree east longitude. And another point y, that point y is on latitude gamma degree north and longitude beta degree west. So to find the distance between these 2 points, let us see how we can do it. Let us first sketch the diagram of the earth, assuming this is the earth. So next we now try to write the common latitude, which is the gamma degree north. This is latitude gamma degree north is now drawn, you can see it. This is gamma degree north. Next is to locate the position of x. That position of x is on latitude gamma degree north and longitude alpha degree east. So let me draw the alpha degree east, the longitude alpha degree east. Look at it. There where the two crosses is the position of x. So next I will locate y. The point y on the earth's surface also I will locate it. But y, look at it, is on longitude beta degree west. So let me draw beta degree west, the longitude. Look at the longitude beta degree west is now drawn, and I have marked my position y. Now to find the distance between these two places x and y that happens to be on the same latitude gamma degree north, what I will do, let us see. The distance between them is nothing but the length of this arc. The 2 points are on the same latitude, and that latitude is a cycle. So distance between those 2 points will be given by the length of this arc. Look at the arc in blue. That arc subtend an angle theta at the center of the latitude. Look at the angle theta. Can we see the theta now? The radius of this latitude is now denoted by small letter r, because this latitude, its radius will not be the same thing as radius of the earth, as you can see from the drawing. Even from the equator, as you move to the poles, either the north pole or the south pole, the latitude keep reducing in radius. You can see radius of that latitude is denoted by small letter r. Therefore, to find the distance between those 2 points x and y, which we said already is the length of the arc xy, so the formula to use is now theta over 360 multiplied by 2 pi small letter r, where small letter r means the radius of that latitude. But the problem that we have here, in most cases, the radius of any latitude will not be given. What is usually given is radius of the earth, and this radius of that latitude is not the same thing as the radius of the earth. So which means we have to get an expression in terms of radius of the earth that is equal to radius of this latitude. So radius of this latitude, which is small letter r, is the same thing as capital letter R cos gamma, where capital letter R means the radius of the earth and the angle gamma is the angle of the latitude. Radius of any latitude is simply equals to radius of the earth multiplied by cos gamma, where gamma is the angle of that very latitude. So we can now rewrite this formula. We will now have distance xy, meaning the length of arc xy, to be equals to theta over 360 multiplied by 2 pi capital letter R cos gamma. I have replaced the small letter r by capital letter R cos gamma. So to find the distance between any 2 points that happens to be on the same latitude, the radius to use instead radius of that latitude, because it would not be given in the question, you use capital letter R cos gamma, where gamma is the angle of that very latitude. We will take examples. Starting with example 1, it says point x is on latitude 60 degree north and longitude 20 degree east, and another point y is on latitude 60 degree north and 50 degree west. Those 2 points x and y are points on the earth's surface. The question asked here is to calculate the distance between x and y along the parallel of latitude. The radius of the earth asked used here is 6,400 kilometers, and the value of pi asked used here is 22 over 7. Solution to this problem: what we do first is to draw the diagram of the earth and try to mark the position of x and the position of y. So let us draw the diagram of the earth. This is the earth. This cycle represents our earth. So looking at the question, we can see that the point X and the point Y, what they have in common is latitude 60 degree north. Look at it. They have same latitude, which means the 2 points X and Y are on the same latitude, and that latitude is 60 degree north. So let us draw a sketch of this latitude. This is the latitude 60 degree north. You can see it. So next is to get the position of X exactly. That position X is a point on the Earth's surface, 60 degree north, longitude 20 degree east. So let me mark or draw the longitude 20 degree east. This is the 20 degree east. You can see it. Let me draw it. Look at the longitude 20 degree east. Point X is where the latitude 60 degree north crosses the longitude 20 degree east. That is the point X. I will now move ahead and get the position of Y. Y, apart from latitude 60 degree north, it is also on longitude 50 degree west. So I will now draw the longitude 50 degree west. Look at the longitude 50 degree west. Let me draw it. Look at it now. This is 50 degree west longitude, and where the latitude 60 degree north crosses the longitude 50 degree west, that is the point of Y. Now the distance between those 2 points is nothing but the length of this arc. Look at the arc in blue, and that arc obtains an angle theta at the center of that latitude, and the radius of that latitude is denoted by small letter r. So let us move. We continue. We now set the distance between those 2 points X, Y is given by the formula theta over 360 multiplied by 2 pi r, where this r is small letter r, meaning the radius of that latitude 60 degree north. But the radius of this latitude, like I have said, it will not be given. What will be given all the time is radius of the Earth. So which means we have to write that expression in terms of radius of the Earth, that is equals to radius of any latitude. So substituting, we will now have distance xy to be equals to theta over 360 multiplied by 2 pi big R cos 60 degrees. And the big R is the radius of the Earth, and that cos 60, the angle 60 is the angle of that latitude. You can see it. The latitude of X and Y is latitude 60 degree north. Theta will be determined by difference in their longitude, as these 2 points X and Y are in the opposite direction. One is east, the other one is west. So the rule tells us we add. So the longitude of X, which is 20 degree east, plus the longitude of Y, which is 50 degree west, we add to get 70 degrees. That is the value of theta that we needed to use in this formula. So substituting to get the distance xy, we will now have xy equals to 70 degrees over 360 degrees multiplied by 2 multiplied by pi. Pi is 22 over 7 multiplied by 6,400, the capital letter R, radius of the Earth, then multiplied by cos 60 degrees. So we continue. We'll now get the value of cos 60. The value of cos 60 either from your 4-figure table or from your calculator is 0.5. So we now substitute cos 60 degrees by 0.5. So finally we will now have 70 over 360 multiplied by 2 multiplied by 22 over 7 multiplied by 6,400 multiplied by 0.5. Evaluating this correctly will now give the distance to be equals to 3,911.11 kilometers. That is the distance between point X and point Y. Another question says an aircraft fly from town X. The location of town X is latitude 50 degrees south and longitude 50 degrees east. That aircraft fly to another town Y, and the location of Y is latitude 50 degrees south and longitude 80 degrees east. If it takes 5 hours to reach Y, meaning to reach town Y from town X, the question asked is to calculate the speed of the aircraft. And the value of R asked to use here is 6,400, and the value of pi given in this question is 3.142. Solution to this question: what we do first all the time is to sketch the 2 points on the Earth's surface. So what we do first is to draw a sketch of the Earth. This is the Earth. This cycle represents our Earth. So look at the 2 points. Look at the 2 points X and Y. They have latitude 50 degrees south common to them. Look at it. Both of them are on latitude 50 degrees south. So I will draw latitude 50 degrees south next. And next I will draw latitude 50 degrees south. Look at it. This is latitude 50 degrees south. The 2 points X and Y are both on this latitude. So I will get to the location of X exactly. The location of X, I will now use the longitude of X. That longitude of X is 15 degrees east. So I will draw that longitude. Look at the longitude 15 degrees east. And that will be the point or the location of X. I mark X. You can see X now in the drawing. That is the position of X. So I can move ahead and locate Y also. I will now use the longitude of Y. Look at the longitude of Y. The longitude of Y is 80 degrees east. So let me draw that longitude. The longitude 80 degrees east is this one. Look at it now. You can see 80 degrees east, far away from 15 degrees east, but in the same eastern direction. And I mark my point Y. Now the distance between those 2 points is nothing but the length of this arc. Look at the arc, and that arc subtends an angle theta at the center of that very latitude 50 degrees south. The length of this arc XY would now be equals to the distance between those 2 points X and Y. The formula to use to find this distance XY is given by the formula theta over 360 multiplied by 2 pi capital letter R cos 50 degrees. Initially it was theta over 360 multiplied by 2 pi small r, but that small r, which is the radius of the latitude, because the radius of the latitude is not given, so we replace that small letter r by capital letter R cos 50, where 50 is the angle of that latitude. So we continue to get theta. Theta in this case, the difference in their longitude, if the 2 points are on the same latitude, theta will now be obtained as difference of their longitude, and the difference in their longitude will simply subtract 15 degrees from 80 degrees. So we'll have theta to be equals to 80 degrees minus 15 degrees. That will give answer 65 degrees. Why do we subtract? Because the 2 points X and Y, the longitude of X and Y happens to be in the same direction. Remember, in the first example that we have seen, the X and Y are in the opposite direction, the longitude. There we add. But if the longitude is in the same direction, we subtract. We subtract the smaller longitude from the higher longitude. So we continue and substitute. In our formula, we now have this theta xy to be equals to 65 d theta divided by 360 multiplied by 2 multiplied by 3.142, the value of pi given in the question, multiplied by 6,400, the value of capital letter R given in the question, and multiplied by 0.6428. This is the value of cos 50 degrees from either your calculator or from the 4-figure table. So multiplying these values correctly will now give answer distance xy to be equals to 4,668 kilometers. That is the distance between X and Y. But the question asked here is to calculate the speed of the aircraft. But the aircraft, after flying from X town X to before it reaches town Y, the time it took is 5 hours. This is it is given in the question. So we remember the connection, the formula that connects distance, speed, and time. This is in our physics. So speed is now given by the formula distance over time. If you remember, if you are a physics student, speed equals to distance divided by time. The time taken here is 5 hours, is given in the question. We have calculated the distance between the 2 points X and Y, which is 4,668 kilometers. So we have to substitute it to obtain our speed. So substituting, we will now have 4,668 divided by 5. 5 is the 5 hours given in the question, the time taken by the aircraft to reach town Y. So dividing this correctly will give the answer as the speed of the aircraft to be equals to 933.6 kilometers per hour. This is the speed of the aircraft. Another example, it says a plane started at airport X. The location of the airport X is latitude 15 degree north and longitude 30 degree east. And that plane, it flies due west to another airport Y. If it takes 12 hours at a speed of 500 km per hour, the question asked here is to find the longitude of Y. The joint value of 2 pi r is now equals to 40,000 kilometers. This is what is given in the question. We replace 2 pi r by 40,000 kilometers. Solution to this problem, what we do first all the time is to make a sketch of the earth and try to locate the places given in the question. So this is the earth, and this is the earth, so we try to locate the point X or the airport X. And the airport X is latitude 15 degree north and the longitude 30 degree east. So let me locate airport X first. Longitude 30 degree east and latitude 15 degree north, look at it. So that is the point X. You can see point X on the earth surface. So the plane starts at X and the question says it fly due west. Look at it in the question. It says due west. Due west means flying along the same latitude from airport X to another airport Y, and that Y is due west of X, which means the two airports X and Y are on the same latitude, and that latitude is 15 degree north. So I will try to locate Y. You can see the point Y is due west of X. So we continue. The distance between them is what we need to find. Distance between them is given by this formula, speed multiplied by time, because in the question we have the speed and we have the time. That plane from airport X to reach airport Y, it takes 12 hours, and the speed of the plane is 500 kilometers. Look at it in the question. We have 12 hours as the time and the speed as 500 kilometers. So what we need to do to get the distance, we now multiplied 500 by 12. So multiplying this correctly gives answer 6,000 kilometers. The distance between airport X to airport Y, the air distance is now 6,000 kilometers. So we continue. But that distance between the two airports is nothing but the length of this arc that you can see in the drawing. Look at the arc in blue that connects point X and point Y. And that arc obtains an angle theta at the center of that latitude. Look at the angle theta. And the radius of that latitude is small letter r. You can see it in the drawing. So we continue. Distance xy, meaning the length of arc xy, is given by the formula theta over 360 multiplied by 2 pi r cos 15 degrees. 15 degrees is that angle of their common latitude. But the value of cos 2 pi r is given as 40,000 kilometers. And we have the distance xy as 6,000 kilometers. So what we now find, what is missing in this formula is the angle theta. Is the angle theta that we needed to find. So we continue in our substitution. We have 6,000 kilometers equals to theta that we have to find over 360 multiplied by 40,000 multiplied by 0.9659. The 6,000 is the distance that we have calculated, and the 40,000 is the value of 2 pi r, while 0.9659 is the value of cos 15, either from the table or from the calculator. So we continue to get theta. Theta made subject of the formula will now have theta to be equals to 6,000 multiplied by 360. Everything divided by the product of 40,000 by 0.9659. We continue. Multiplying and dividing correctly give theta to be equals to 55.9 degrees. This is the value of theta. This theta is not the longitude of y, but as x and y are on the same latitude, theta will now be determined by difference in their longitude. The difference in the longitude of x and that of y is what will give us the theta, 55.9 degrees. So we now look at the longitude of x. The longitude of x is 30 degrees. Can I subtract something from 30 degrees to get 55.9? The answer is no. So which means it's the addition that we need to do of the two longitudes to get this 55.9. So therefore, the theta will now be equals to longitude x plus longitude y. If the value of theta is smaller than 30 degrees, meaning the longitude of x, so what you need to do there is to subtract to get the theta. But as the value of theta 55.9 is bigger than the longitude of x, which is 30 degrees east, so what we need to do to get that theta, we add the angle theta. Remember, we add if the two are in the opposite direction, but we subtract if the two are in the same direction. So the addition will give us theta to be equals to 55.9 as our theta equals to 30 degrees plus longitude y. It is longitude y that we want to find. So collecting like terms, we now have longitude y to be equals to 55.9 minus the 30 degrees. That angle 30 degrees is the longitude of x. So subtracting 30 from 55.9 degrees will give us as 25.9 degree. So the longitude of y is now 25.9 degree west. The direction is west because we have added. If you put east, then you are wrong. East means you subtract, but it's not subtraction that we need to do because the size of theta is bigger than 30 degrees. This is how we answer this problem. Another example is says a plane start at x and the location of that x is 35 degree north and the longitude 10 degree east, and it fly due east to another airport y, and the airport y, location of the airport y is 35 degree north and the longitude 30 degree east. Then it flies due south to another airport z, and the location of the airport z is 20 degrees south and the longitude 30 degree east. The question asked here is to find the total distance traveled. The value of 2 pi r given here is 40,000 kilometers. This is another real-world problem. Solution to this problem, what we do first always is to sketch the diagram of our Earth and try to mark or to locate the places given in the question. So this is the Earth, this is our Earth, and let us see the 2 points x and y. The two, you can see that they are on the same latitude, 35 degree north. Look at the 35 degree north, x and y are on the same latitude. So let's locate the places x and y. So I will now draw the latitude 35 degree north. Look at it. This is 35 degree north. So I will mark the position of x. The position of x, look at it, it is on longitude 10 degree east. So I will draw the longitude 10 degree east. Look at the 10 degree east there. I can mark my point x. I can equally mark my point y, but point y is on longitude 30 degree east. Look at it. So I will now draw longitude 30 degree east. Can we see it now? This is longitude 30 degree east. You draw it behind or far away from x, because as you go eastern direction, the longitude, the angle of the longitude is increasing. Next, I can now see that the 2 points x and y are on the same latitude, and the distance between them is nothing but the length of that arc xy. You can see it in blue, and that arc obtains an angle theta, and the radius of that latitude you can see in the drawing is small letter r. So let us see whether we can find this distance between those 2 points x and y that happens to be on the same latitude. So distance xy is now equals to theta over 360 multiplied by 2 pi r cos 35 degrees. 35 degrees is the angle of their common latitude. So substituting, we now have 20 divided by 360 multiplied by 40,000 multiplied by 0.8192. Now, where do I get the 20? The 20 is the value of theta. And that value of theta, remember, if the two happens to be on same latitude, the theta will now be difference in their longitude. So the longitude of x and the longitude of y, the difference in their longitude will be your theta. But those longitudes x and y, longitude of x and y happens to be in the same direction. So there the rule tells us if it is same direction, we subtract to get theta. So subtracting 10 degree longitude from 30 degree longitude give the theta, and that theta will now be 20, because 30 minus 10 will give answer 20. The 40,000 kilometers is the value of 2 pi r given in the question. And the 0.8192 is the value of cos 35 degrees, either from your calculator or from the four-figure table. So we can move. Multiplying these values correctly give answer 1,820 kilometers. That is the distance between the 2 points x and y. We continue. So this plane from tower x or from airport x to airport y, the distance traveled is 1,820 kilometers. So we continue, but from that airport y, the question tells us that it flies due south. From airport y, it now moved to airport z. And that airport z is on the latitude 20 degrees south, but longitude 30 degree east. Look at the 30 degree east, meaning it is on the same longitude as y. You can see the longitude of y is 30 degree east, and the longitude of z is also 30 degree east, which means the plane now move along same longitude. So we now try to draw the latitude 20 degrees south, and we try to mark the position of z in the point z. Look at it. That z is on the same longitude as y, which is 30 degree east. So we also find the distance between y and z. That distance between y and z is another length of arc. Look at the arc yz. That arc yz that happens to be along that same longitude 30 degree east would now be the length of that arc, would now be the distance between y and z. That arc subtends an angle alpha at the center of the longitude. So there we continue. But the radius of that longitude, remember, is capital letter R, the radius of the earth. So we now find the distance between y and z. Distance between y and z is given by the formula alpha over 360 multiplied by 2 pi r, where alpha is the angle subtended at the center of that longitude by the arc yz. And we now use capital letter R because we are now calculating distance along a great cycle, because that longitude is a great cycle. So we now substitute. We now have distance yz to be equals to 55 divided by 360 multiplied by 40,000. The 55, where I have 55, is the value of alpha. Alpha, remember, you can see it in the drawing, is the angle subtended by that arc yz. And that y and z happens to be on same longitude. So the angle subtended there, alpha, I didn't use theta because you would not be confused with the other theta. I used angle alpha just to denote the angle subtended at the center of the longitude. So that angle alpha will now be determined as difference in their latitudes, because the 2 points y and z happens to be on the same longitude. So the angle at the center will now be obtained as difference in their latitude. The latitude of y is 35 degrees north. Look at it in the drawing. And the latitude of z is 20 degrees south. Look at it also in the drawing. So that angle alpha will now be equals to 35 degree plus 20 degree. That will give answer 55. That is the 55 we have used in this formula. Why we added? Because the latitude 35 north and the latitude 20 degrees south, the two are in the opposite hemispheres. So the rule tells us that we add to get the angle. So there we continue. Simplifying this correctly give answer 6,111 kilometers. That is the distance from y to z, from airport y to airport z. But the question asked here is to find the total distance traveled. Total distance traveled will now be equals to the addition of the two distances, meaning from city x or airport x to airport y, and from airport y to airport z. So the total distance will now be equals to the two distances added together will give the total distance traveled by the plane. So we now add 1,820 plus 6,111 kilometers. That gives answer exactly 7,931 kilometers. That is the total distance traveled by the plane in these two separate journeys. This is the end of this lesson. Let us now revise some of the things that you have learned in this lesson. In this lesson, you have learned that when 2 points are on the same parallel of latitude, the distance between them along that parallel of latitude is given by the formula distance equals to theta over 360 multiplied by 2 pi small letter r, where theta is the difference in their longitudes and small letter r is the radius of that latitude, and the pi is a constant value given in the question. But the problem is not every latitude that you have it is radius in the question. So we have to rewrite an expression in terms of radius of the earth that is equals to radius of any latitude. But that expression, you have learned that expression small letter r is given by the formula capital letter R cos gamma, where capital letter R is the radius of the earth and gamma is the angle of that common latitude. Hence, we can now rewrite the formula above. The distance between any 2 points is now given by the formula distance equals to theta over 360 multiplied by 2 pi capital letter R cos gamma, where capital letter R is the radius of the earth given in the question and gamma is the angle of that latitude.